As you can see here, that whenever you just increase the voltage level, so the if the when the applied level of applied voltage reaches a sufficient high value, the electrons, instead of trying to travel even faster, transfer to the high energy band, which is empty. That means the higher energy band then gets empty, and the less mobile. As a result, the current flow decreases. That means they has been forbidden to go through to a certain shield that has been created by themselves. Okay, and exhibiting negative resistance phenomenon. Now here you can see that the electron transfer from a lower energy level to a higher energy level is called transferred electron effect. That is known as the transferred electron effect. If the voltage level is increased even further, the mobility of the electrons in the higher energy band begins to improve, resulting in an increased current. Another reason is that the Gunn domains, the effect of the Gunn domains. What are the Gunn domains? The frequency of the oscillations in the gallium arsenide has to do with the formation and the transit time of the electrons, which form themselves in electron bunches. The negative resistance effect is an important factor in understanding the Gunn oscillator. However, the negative resistance effect alone does not explain everything that is happening inside the oscillator. The other important element is the formation of domains or Gunn domains. What are the Gunn domains? Just look after it. The formation of Gunn domains means how the oscillation came into the fact. I have to just make you understand with a simple observation that look after it. First of all, the energy level was empty. After the increasing energy level, there is a narrow forbidden energy gap has been created. Then it is partially filled energy band gap. Partially filled means in that particular part to that particular part, and there is a fulfilled energy band is this particular part, and that is the empty energy band. So there are three parts, and there are two overlapping parts. That is a narrow forbidden energy band gap between empty energy and partially filled, and there is a forbidden energy band gap between the partially filled and fulfilled energy band. Whenever it is fulfilled energy band gap, there is fulfilled energy band gap, that means there are no other free electrons exists in that kind of material. Okay, so if there are no existing free electrons are there, the current flow will be decreased, and the resistance will go through to the negative resistance direction. The other electrons will flow in the different directions. Okay, now uh, go back to the point of Gunn domain. Now you have to understand that the negative resistance effect alone does not explain everything that is happening inside the oscillator. The other important element is the formation of domains, that is Gunn domains. That means these domains means the amount of free electrons available in the gallium arsenide depend upon the density of the n-type material doped in the gallium arsenide. Since the density of doping is not necessarily uniform across the gallium arsenide, these are fewer free electrons where the doping density is low. Fewer free electron means less conductivity, and therefore the potential difference in such an area becomes greater than the area where there are more free electrons. Hence, as the applied voltage is increased, eventually the transferred electrons effect takes place at this area. First, due to a sufficient voltage gradient resulting in a negative resistance domain. The domain as described above is considered to be unstable. What is happening is such a electrons in front travel forward rapidly, and once behind bunch up electron bunches. This way the whole domain moves across the slice and toward positive with an average speed of the 10 to the power 7 centimeter per second. As the transferred electron effect takes place in a domain moving electrons less conductive higher energy bands, it is quite inevitable and understanding that how that negative resistance creates, because these Gunn effects will not go to the simple disposition. that will go through to the bunch of positions and bunch of parts of certain contacts. So uh, these kind of things that has been going through to the bunch of parts, this type of things known, these type of zones are known as Gunn domains. Okay, now let's go to the next section. After the theory we have to go through the experimental section. Now that is the Gunn oscillator. As you can see a picture of the Gunn oscillator, there are that is the two pictures in front side, that is the front part side that has been connected. As you can see there are two chambers on it given, and one part is quite upper side, that is the tuning part, and as you can see this part is the output section. That means it's the input section, that is the output section, and that is the tuned crystal that has been connected to the Gunn oscillator part, just tuned to tune the circuit. Okay, although the oscillator is designed to prevent spurious mode oscillations, tuning features are provided with the oscillator in case fine adjustments are necessary. That means that has been used to create the fine adjustments. So what is the oscillator? Oscillator means it is a frequency generator. By using the negative resistance, these kind of items, or these kind of what can I say, components that use the negative resistance, they create the oscillation. That means that they create a frequency that it is being used as a frequency generator. Okay, so how can you set up this kind of Gunn oscillator? That is pretty much important to know. So that is a setup requirement. As you can see here, there is a power supply. Here you can use the ammeter, and there has been used the voltmeter to adjust the power supply, and the power supply has been used in the Gunn oscillator parts. Then the variable attenuator has been placed, then the block of waveguide to coaxial adapter, and there is a thermocouple mount, and there is a power meter to check the power of that Gunn oscillator, that what is the output of the Gunn oscillator. Now look very much clearly that what power supply gives. How can you connect the power supply? Okay, now uh, just go through to this kind of arrangement, that is the ED3000 Gunn oscillator part. In that particular point there will be used as there will be a variable attenuator should have to be used, and just if we just want to see the attenuator, I will show you. Just wait. Okay, now you can see this is the part of the attenuator. Okay, this is the part of the attenuator, and this is the part of the attenuator. Now we will heading towards our next our section of the Gunn oscillator part. Just moving forward, the Gunn oscillator part, how the arrangement will go through. Now that is the arrangement part of the Gunn oscillator. Now you can see in that kind of power supply we will just give the wave through to the Gunn oscillator input section. After variable attenuator connection, there is a waveguide to coaxial adapter, and there is a coaxial cable after that will go through the thermocouple mount to, and after that is the output section of the arrangement. As we know, the thermocouple mount that takes the thermal or heat energy into the electrical energy, and we will then measure the power from that kind of meter, the power meter. So there is a current versus voltage characteristics. So they have been told to set the voltage 4 volts and set the variable attenuator to 10 decibel. There is a variable attenuator, and this will ensure proper isolation of the Gunn oscillator. After isolating Gunn oscillator with 0.5 volt increment, we can find out each of the voltage increase that and take the current reading from the source, and we can find out, after finding out that, we can really find out the power of that part.